Hello everyone, this is Shekhania of Shri Venkateshwar College of Engineering. So today I'm here to cover the topic of subject Automata Theory and Computability of 5th Sem Engineering. So I'll be covering the topic that is minimization of DFA. First we'll go through the contents. The contents are what is about DFA, minimization of DFA, table filling algorithm which comes under minimization of DFA, steps involved to solve, where we'll be solving one of the problem, and conclusion. DFA, basically deterministic finite automata. What is it? So the term deterministic indicates for any given state and input symbols there is exactly one next state. DFA are particularly useful in the study of formal language and regular expression. They can be employed to recognize whether the given input string belongs to a specific language or not. And finally, we can say that DFA consists of finite set of states, like transition state, initial state, and all, which we'll be learning further. So various states are the Q represent as a set of states, like all of the states which will be using in particular solving a DFA. Set of inputs represented by sigma, which will be one or zero, A and B. Next is transition function, the how many transitions are taking place from one state to another in respective to A and B. Next is uh, designation initial state. So basically, what is the initial state? Initial state will be, and next is the final state. So it is the given we have given a set in which all DFA is represented, like all the states of DFA are represented. According to this state, we'll be solving the further questions. And our core topic, that is the minimization of DFA. So we will be going some of the gist like what is DFA. So two states P and Q of DFA are equidistant if and only if the PW and QW states are leading to final state, or PWQ are leading to non-final state. So any of the condition will be satisfied. To find equidistant of DFA, we'll be using table filling algorithm. So now we saw like we'll be using table filling algorithm. So we need to go through certain steps in solving this problem. So first is remove non-reachable states from the start state. Second is we need to make pairs and mark them as an X mark. Next we need to check if one of the pair in given combination, if any of the pair is having X mark, that is the cross, then we need to mark the given combination. That is the third step. That is, for each pair PQ and for each symbol A belongs to E, find the coefficient of transition PA is equal to R and transition QA is equal to S. If the pair RS is marked on table, then mark the parent PQ. Next, we need to repeat the step 3 until we get a whole table marked with S. The table we'll see in the further stages. And next is we need to draw the minimized DFA. What is the final DFA we'll get? So we'll be solving this problem. So here you see that there are 5 states, that is Q0, Q1, Q3, Q2 and Q4. According to the first step of table filling algorithm, we need to check if the initial state, that is Q0, is reachable to all the other states. So here we can see Q0 is reachable to Q1, it's also reachable to Q2. From Q2 it's reachable to Q3, and from Q3 is reachable to Q4. So basically it's reachable to all of the states like Q1, Q2, Q3 and Q4. It's reached to all the states. And here the final state is Q4. In the next slide, now we will draw this kind of table for the given DFA problem. In this, while drawing this table, while drawing the vertical column, like this column, we need to leave the starting state, that is the initial state, which was our Q0. So in this, we have left in vertical Q0. Then we have to leave the final state in the horizontal, that is Q4. And then we need to draw this table, and that in this table we need to mark all the combinations of the final state. So the all the like how what are the combination that final state is having, that is Q0, Q1 and Q2, Q3, will mark all the state. Here we don't have any of the Q4 state, so we won't have any of the vertical column. We'll only have the horizontal combinations which we are going to mark. So how to solve this table? In the first, we need to take combination of Q0 and Q1. Will represent a combination Q0. Now we have to check that Q0 reaching A. So when Q0 reaches to A, it reaches to Q1 state. So we'll write here Q1. Next we'll check the same for Q1. So when Q1 has a state of its own, that's the A, then it's reached to Q1 only. So we'll write Q1. Similarly, we'll check where the Q0 state reaches if we had B state. So it reached to Q0. So we'll have Q0 over here in the B state. And the Q1, where does Q1 reach? In the B state, it reached to itself. It reached to Q3. So we'll write Q3. Similarly, we need to check that if any of the state is marked over here. But we have to check if Q1 in this table doesn't exist, so we'll keep aside. And Q2 Q3, Q2 Q2 Q3 also doesn't exist. And if we see from this side, Q2 Q3 exists, but currently it is unmarked, so we'll make this state Q0 Q1. Presently we leave it as a unmarked state. And there's also a rule to further simplify if some of the states are left unsolved. Next we'll see, so we have checked for Q1 Q0 Q1. Now we'll check for Q0 Q2. For Q0 Q2, same as it's reaching to A is Q1 Q1, and reaching to B, that is Q0 reaching B is Q2, and Q2 reaching B is Q2 itself. So this state doesn't exist. So we will keep this Q0 Q2 state as unmarked because this state doesn't exist. Next we'll check for Q0 Q3. In Q0 Q3, A is Q1 Q1, like Q0 reaching A is Q1, Q3 reaching A is Q3. Similarly, Q0 reaching B is Q2, Q3 reaching B is Q4 here. So this combination, this state is marked. Here you can see as Q4 and Q2 is already marked, as according to the rule any one of the states should be marked. So we have Q2 Q4 status marked, so we'll mark Q0 Q3. So we have marked here Q0 Q3 state. Next we'll check for all, so basically we need to check for all the blocks that are unmarked. Now we'll check for Q3 Q1 and Q2. Q1 Q2, same A as Q1 Q1, and Q1 reaching B is Q3 and Q2 reaching B is Q2. Here we can see Q1 reaching B is Q3 and Q2 reaching B is Q2 itself. So Q3 Q2, we can make out Q3 Q2 is not marked and Q1 Q1 is also not marked. So for now we won't mark Q1 Q2 state. We'll move to further. We'll have Q1 and Q3. We'll check for Q1 and Q3. Similarly, for reaching A is Q1 Q1, and for reaching Q1 reaching B is Q3. Q1 reaching B is Q3, and Q3 reaching Q4 as B state is Q4. We have seen Q3 Q4, like vice versa is also okay. So Q3 Q4 state is already marked, like according to rule this state is not marked, this state is marked. Since any one of the state is marked, we are going to mark this one. Since in the previous slide we have checked for Q0 Q1 to Q1 Q3 till this state, now we'll check for Q2 Q3. Applying the same rule, reaching A is Q1, Q1, the combination of Q2, Q3, and reaching B is Q2, Q4. Since we have Q2, Q3 marked, like that is Q4 or Q2 is marked, we will mark this state. Like according to the rule, any one of the state should be marked. This is unmarked and this is marked. So going with the rule, we'll mark the states. After solving, like after combining all the state once, we have come to know that this and all states are marked, but more than one state are still unmarked. So we can again go through one more round of checking to check if the further states can be marked. So to know the further states is marked, we can again solve it. Now we'll start checking from first state, that is Q0 Q1. Q0 Q1 Q11 reaching A state, and Q2 Q3. Since Q2 Q3 is marked here, according to rule, this state is marked, this is unmarked, so we're gonna mark this state. Similarly, now we check for Q0 and Q2. Q11, Q1 Q1 and Q2 Q2, that is reaching state of A and B of combination Q0 and Q2. Both of the state doesn't exist, so practically they are not marked. So we are not gonna mark this state. Next we'll check for Q1 and Q2. Q1 Q2, A is a Q1 Q1 and B is Q3 Q2. Here you can see Q3 Q2 state is marked. So since we satisfy the condition, we are going to mark Q1 and Q2 state. So here Q1 Q2 state is marked. Next, the remaining state, like almost we have Q0 Q0. Again we'll check for Q0 Q0, but Q0 Q0, we, because this is the only state left after finding all the states. Further, if we solve this, Q3 Q2 doesn't exist. So there's no now for this we have reaching state Q1 Q1 and Q2 Q2. Since Q1 Q1 both doesn't exist, so this state will remain unmarked till the last. So after further solving, we have got this final table and this state is unmarked. From here we can conclude that Q not Q1 combination will stay unmarked. This is the final table which we get. Now according to this table, we will be making the DFA diagram. Uh, uh, because the Q naught and Q state are unmarked, we'll combine this state together and rest all state will leave as the single. So now here we have the final DFA, the minimized DFA. Remember we had such a big diagram. Now we have come to this small DFA thing. So we have Q naught Q2 state which is unmarked. So we have combined this both states. So from the input, Q2 and Q naught both has B state going to itself. We have self loop, and A going to Q1, and Q1 has self state A and it's going P to Q3, and this is have Q5, that is the final state, which is going B to Q2 and A to Q1. So you can see this final state. So here you can see this is the final DFA which we want, so that we have done so many steps to conclude with this step. So that was only for the minimizing of DFA. Hope you understand. Basically, minimizing of DFA is a crucial process in the field of automata theory and formula language. The primary goal of this is to simplify the DFA while preserving its language and organization capability. This is the main goal we needed to reach, and we finally reached and we found the simplified DFA. Hope you like this and you hope you understand, and thank you. Bye.